And again, really watch out for the fact that the first subshell is not L equals 1, it's L equals 0. How about if we were going to say go on to the fifth shell? What would be the L's for the fifth shell?
0, 1, 2, 3.
Like this?
I guess there could be 4.
L equals 4, you mean?
Yeah.
Now remember that whatever shell you're in, that's how many subshells you have. The first shell has 1 subshell.
So
The second shell has 2 subshells. So how many subshells should this have? 5. So do we need the number 4?
yeah.
Do we need the number 5?
No.
Because we already got the number 0. So even though there's 5 subshells, it only goes up to 4 because we start with the number 0. We could have just used our rule that L goes from 0 to n minus 1. That ensures that you, whatever n is, if you have that, you'll have that same number of subshells. By the way, what letter would this correspond to?
S, P, D, F.
Now here's one that you don't normally get to in normal chemistry, but at this point they just start using the alphabet, so I think this would now be G. You can see they didn't really follow alphabetical order for these first letters. There's some weird historical reason why they have S and P in here. I think it has to do with the spectrum somehow. But at this point, then you start following the alphabet. So the next one would be H, if you ever got to that. But these don't come up too much. If they did, people would probably just use the L numbers. What shell does this spot in the periodic table represent?
L equals 0. Oh, which shell? 1.
Yeah. And which subshell?
0.
Yeah. And what's the letter for that? Yeah. And what's the letter for L equals 0?
S.
Yeah. This is called the 1s block. How about what shell does this represent?
2s.
Yeah. Shell 2 and subshell S. And how about here?
3s.
How about this one?
So 2s, 3s, so 4s.
Good. Is this 5s?
Yeah.
Yeah. So this is what's called the S block. And what would the L number be in the S block?
0.
Yeah, although oftentimes it's more conventional just to call it X instead of L equals 0. How many electrons can fit in the S block?
2.
Yeah, how do you know?
Um,
How do you know from the periodic table?
oh, because there's only 2
Columns.
Yeah.
Yeah, the number of columns tells us how many electrons will fit. Okay? Well, what block would we call this?
P.
And which shell?
Well, 2.
How do you know it's not 1p?
There's no 1.
Yeah, now that's it seems obvious, but that's an important point. After all, this is the very first p block. This is the very first p block, so it might seem natural that it's 1p, but this tells us very important news. There is no 1p. So the first p block has to be 2p. All right, and then this would be? And this would be?
4.
Good. By the way, what block is helium in?
Is it S?
And what shell?
1S.
Yeah, this is still a 1s. In some ways, it might be more appropriate if helium was put at this point in the periodic table. But it's put over here because it's a noble gas like these other ones. But in terms of electron configuration, it kind of belongs over here. Okay. What subshell are we filling in here?
3D.
Why not say 2D?
There's no.
That's right. Now here's where people really tend to make mistakes. They say, aha, this is the first D block, but it's not 1D or 2D because we just memorized there is no 1D or 2D. The very first D block is the 3D. All right, so this is where this becomes very important for filling in the periodic table. It's very tempting to think that's, after all, this is 4s, so another thing that's tempting is to think that this is 4D. So notice that you can have different numbers in the same row of the periodic table. Now we're getting different numbers in the same row of the periodic table. So again, there's plenty of room here for people to make careless mistakes. Okay, do you have your textbook with you?
Yeah.
All right. So we might need that periodic table there. So let's turn to the periodic table so we can consult it as needed. Okay. How many electrons can fit in a D subshell?
10.
How would you know from the periodic table?
That's just that across.
Yeah, it looks like you have that memorized. But yeah, you could always figure it out from the periodic table because there's 10 columns in the D block. How many electrons can you fit in a P subshell?
6.
Because there's 6 columns. So those are things we don't have to have memorized because the periodic table tells us so. All right, which block is this?
4D.
So again, notice that the D number is always different from the other numbers in the same row. So if I was doing a test question about the periodic table, I would just write down this whole table and label all the blocks. So I don't have to keep figuring it out over and over. Because if you have to keep figuring it out over and over, you're likely to make a careless mistake somewhere along the way. But if you just number it systematically from the start, you should be in pretty good shape as long as you remember what's the very first S block? That would be 1s. What's the very first P block? 2P. And what's the very first D block?
3.
Yeah, so if you just remember where to start, then the rest of the table becomes straightforward. Now you know that there's some elements that don't really fit in the periodic table, so kind of in desperation they shove them in down below. Which subshell would we be filling in down here? Yeah. Now this is the very first F block, so which numbered shell is this?
4.
How do you know it's not 3F? Because there is no 3F. All right, so again, this little table here seems kind of trivial, but it really is the key to unlocking what the blocks are in the periodic table. So this is a good thing to write down as well. So we can figure out what's the first F block. It's 4F, not 5F or 3F. And then this would be, okay. All right, so this is the complete blockage laid out for the periodic table. How many electrons would fit in the F block?
14.
That's right, if you count the columns, there's 14. How many electrons fit in the second shell?
2. No, the second shell, it's the first shell. 6. No, 8. It's F8.
Because there's a 2s block and a 2p, and if you just count the columns, that's 8 overall. How many electrons fit in the third shell?
18.
How did you get that 18?
Because it's 18 across. Like the
Right, so you can take the S and the P, which we already found were 8, and then there's 10 more in the D block. How many electrons would fit in the fourth shell?
That's 1 plus 14, so 34.
18 plus 14?
32.
Yeah, good. So what does the fourth shell have? What has 4s, 4p, 4d, and 4f? 2 plus 6 plus 10 plus 14, which is 32 overall. Okay. So we can see it's pretty straightforward to figure out the number of electrons in any shell just by reading it off of the periodic table, as long as you know what the subshells are for each shell. This is again the key. You have to know what subshells each shell possesses. Now there is a mathematical formula for this. The number of electrons in any shell is 2n squared. You can see that would work when n is 4, because when n is 4, 4 squared is 16, and 2 times 16 is 32. But I'm not really a big fan of using this equation, because it's easy to get confused with the other equations. It seems like you can just read this off of the periodic table. So I think it's better to be able to read this off of the periodic table, but you might use this as a check.